The first one in yellow is x squared. Now x squared, if we graph that just by itself, looks like this. It's a common function, one of our parent functions that we deal with quite often, but we only want to look at x squared where x is less than or equal to -2. That's the domain restriction. So f of x is equal to each one of these three if these domain restrictions are met. So it lives on the x-axis, so it casts a shadow on the x-axis from -2 towards infinity. So we can take our x squared, and if we cover up everything to the right of -2, what we have left is what we're going to graph. Now it continues going on upward and to the left, just at a very steep rate, at a high rate. So let's graph that. 0, 0 is a point, -1, 1 is a point, -2, 4 is a point. 1, 2, 3, 4, and it is less than or equal to, so we're going to include that -2, 4. 3, 9, -3, 9, 3, let's see, that's 4, 5, 6, 7, 8, 9. And it continues on. Just a almost straight line, just a reference point there. So we know it crosses through those points, but also every point in between. And then continue on further because there is no left bound. If we want, we can put a -infinity there because it just continues on. All right, let's look at the rightmost portion, the orange. This is the constant function 4 if x is greater than or equal to 2. Well, here's 2 for x, and the constant function 4 is just a straight line at 4, where y is equal to 4. It's just along this line. At +2, it includes it because it's greater than or equal to, so it's a closed circle. And then it continues on indefinitely. So infinity is greater than x, x is greater than or equal to -2, or x just continues on. We're not bounding that. The middle function. Middle function, this has been giving some people some problems. This is our regular y equals, it's not in slope-intercept form, y equals mx plus b, but we can put it in that form just by rearranging these. This is y equals 3 minus x. If we use our associative property and, the commutative property, and commute these because this is addition, we would have -x plus 3, which can sometimes more easily be seen as -1x, as -1 is the slope, plus 3 is the y-intercept. So if we go up to 3 is our y-intercept, and it's a -1 slope, so that's down 1 over 1, down 1 over 1. Going the other direction, up to the left, up to the left. Now this does not include -2, nor does it include 2. So these are going to be open circles at these points, but it includes all the points between there. We have completed the graph of this piecewise function by looking at each part independently with careful consideration to the domain restrictions. Again, looking at the purple, the middle section, if we ignore all the others, that is -x plus 3. If we look at just the constant function 4 and ignoring the others, that is y equals 4. And then if we look at y equals x squared, ignoring the others, just looking at less than -2 on the x-axis or in that domain, that's the function that we would be looking at.